Hi everyone. Today we will discuss about the operational amplifier different applications. In last session we discussed about the operational amplifier basics and operational amplifier block diagram and operational amplifier symbol pin diagram and its different characteristics. So today we will discuss about the operational amplifier applications. So basically operational amplifier is used to perform in the amplification as well as it can performing the mathematical calculations also. It is used for different linear, non-linear applications. So coming to this, so operational amplifier is a high gain differential amplifier and the gain of that amplifier is in terms of 10 power 5 to 10 power 6 and means generally the ideal op amp is having the gain is infinity but practically the operational amplifier gain is 10 power 5 to 10 power 6. So the different applications of operational amplifier is it linear applications, non-linear applications, and mathematical operations. So the circuit is said to be linear if there exists a linear relationship between the input and output terminals. And similarly, the circuit is said to be non-linear if there exists non-linear relationship between the input and output terminals. So uh, the operational amplifier can be used in both linear and non-linear applications. So the different applications of operational amplifier is inverting amplifier, non-inverting amplifier, follower, mathematical operations, integrations, differentiator, instrumentational amplifier, converters, and log and anti-log amplifiers. It is used in rectifiers also. So these all are the different linear and non-linear and mathematical applications of operational amplifier. Coming to this, first one is the inverting amplifier. So operational amplifier is consisting of two input terminals. Those are inverting input terminal and non-inverting input terminal. So we know whenever we are applying the input to the inverting input terminal, the output is the inverted one. Means whenever you are applying the positive cycle to this inverting, you will get the output as negative cycle. So the inverting input terminal, the input applied to the inverting terminal is either AC or DC. And here the operational amplifier is having the structure closed loop means some output is connected to the input side. So this is the feedback signal and this is connected to the feedback resistor RF. So and operational amplifier follows the negative feedback. So here the feedback resistor is the RF. So for the inverting amplifier, if the input is applied to the inverting terminal, the output is having 180 degrees phase shift with respect to the input. And this amplifier not only amplifies the input signal, it also inverted the input also. Means changingly it's a sign. Operational amplifier will follows the virtual earth or virtual ground concept for doing any operation. So virtual earth and virtual ground concept is nothing but physically, there is no connection. There is no short between the two terminals, but virtually they are short with each other. Means here the inverting terminal and non-inverting terminal are following the virtual earth concept. Means physically there is no connection between these two terminals, but virtually those two are connected to each other. Means whatever the voltage present at this terminal, the same value is also present this one. Means these two are connected virtually. Means whatever the value present is here, the same value is also present here. Means here the non-inverting terminal is connected to the ground. So the value present at this node is equal to the 0 because the value present at this non-inverting is 0. That's why because of this virtual connection, value present at this point also 0. So to performing any operations, we need to assuming Operational amplifier is always following this virtual earth concept. So virtual earth concept is applicable for negative feedback present in the circuit. So it is having the negative feedback. So see here, in this, the non-inverting terminal is connected to the ground. This means 0 volts is applied at the non-inverting terminal of the, because this is connected to the ground, 0 volts applied to the non-inverting terminal of the op-amp. So according to the virtual short or virtual earth or virtual ground concept, the voltage at the inverting input terminal of the op-amp is also 0 volts. The virtual earth ground is applicable for negative feedback is present. So the gain of the amplifier is controlled by negative feedback, and the amplifier is operates in the linear region, not it is entering into the saturation region. It operates always in the linear region or active region only. See here, you are applying the input to the inverting terminal, that's why it is called inverting amplifier. So VA is applied. Uh, so here the current I1 is flowing through the RI, and also feedback current IF is flowing through the RF. So applying Kirchhoff's current law at this node, this will becomes I1 equal to the IF. So see here, this is the point. Here we are applying the input voltage at the inverting terminal, that is -1. The current passing through this R1 is the I1, and current passing through this RF is the IF. By applying the KCL at this point, so KCL means the entering currents are equal to the leaving currents. So here entering current is the I1 and leaving current is the IF. So I1 is equal to the IF. Entering currents are equal to the leaving currents. So I1 equal to IF. So I1 is nothing but VI minus, consider the voltage at this node is Vs. So Vi minus Vs by R. I equal to V by R. So again IF equal to Vs minus V naught by Rf. But what is the value of Vs? The Vs value is 0 because by following the virtual earth concept, this is connected to the ground. Due to this, value present at non-inverting terminal is 0. So the same voltage is also present here. So Vs equal to 0. So by putting Vs equal to 0 and the above equation, that will becomes Vi by R1 equal to minus V naught by Rf. So finally we need V naught value. V naught equal to minus Rf by R1 into Vi. But finally we need gain value. Gain is nothing but V naught by Vi. So this will becomes minus Rf by Ri. So the input voltage is amplified accordance with the input values and Ri. And here that is also inverted. We can identifying that the inverted output by using this sign. So the gain of the inverting amplifier is equal to the minus Rf by R1. So the negative sign is indicating the there is a 180-degree phase shift is existing between input and output. This is about inverting input terminal. So finally, we are applying input to the inverting terminal. Just apply KCL at that node, and by using virtual earth concept, we will simplify the circuit and we get the gain value at the inverting terminal. Next, coming to the non-inverting amplifier. So the non-inverting amplifier means the input is applied to the non-inverting terminal and it will produce as the amplified output. And here for the non-inverting amplifier, the output and input are in the same phase. But in previous inverting amplifier, the output is having out of phase with the input signal. But in this, input and output are in the same phase. So the name suggests the amplifier just amplifies the input without inverting the input signal. That is without changing the sign of the output signal. So here also just non-inverting, apply input to the non-inverting terminal. So the voltage at this non-inverting terminal is V in. By following the virtual concept, virtual earth concept, the voltage at this point is also Vi. So apply KCL at this node, then same incoming currents are equal to the outgoing currents. So always the current going this direction means it is connected to the ground, so it will choose this path only. So by applying KCL at this point, I1 equal to IF. I1 is nothing but Vi minus 0 by R1 and IF is nothing but V naught minus Vi by RF. So by simplifying this equation, finally V naught value equal to 1 plus RF by R1 into Vi. Finally, we need gain value. The gain is nothing but output by input value. So V naught by Vi equal to 1 plus RF by R1. So from this equation, we can say the output voltage is always in phase with the input signal, and the gain of the amplifier also depends on the external connected components RF and RA. So this is about non-inverting amplifier. So the differences between inverting and non-inverting amplifiers are, whenever you are applying input to the inverting amplifier, the output is the inverted output. It gives inverted output. But whenever we are applying input to the non-inverting terminal, the output is having same phase with the input signal. So here, the gain of the inverting amplifier, when used with negative feedback, is directly proportional to the ratio of feedback resistor and input resistor. Means V naught by Vi equal to minus RF by R1. Feedback resistor is RF, input resistor is RA. And the gain of the non-inverting amplifier is proportional to the ratio of RF to RA with some intercept value. That is V naught by Vi equal to 1 plus RF by R1. So these are the some differences between the inverting and non-inverting amplifier. Thank you.